Back up where we left off yesterday. The example A where we had to write all the complex zeros, and now we're going to look at example B. Okay, so I left example A up here. Actually, I just got lucky and the bin queue didn't erase overnight. Okay, so example A is up here. We can follow the same steps. Okay, as we're trying to find all the complex roots or zeros, we want to start by finding our PRRs.
PRR. Which I can go ahead and give those to you.
Well, we're going to find them.
Well, I can find them. I already have them.
Okay. How do I find PRRs?
The constant.
Factors of the constant, which is
-10.
-10.
And leading coefficient.
Factors of the lead coefficient, which is 1. So factors of -10.
Actually, it's not negative.
Over factors of 1. What are factors of 10?
Oh, right here. Plus or minus 1.
Plus or minus
plus
2.
Or minus 2. Plus or minus 5. Plus or minus 10.
What are factors of 1?
1.
Plus minus.
Okay. So in this case, it's a pretty easy list of PRRs, isn't it?
Yeah.
Because everything is over 1. We're only looking at whole numbers.
Yeah.
So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Those are my PRRs. Now, how many solutions is this problem going to have in the end? 3. That means up to 3 of these could be places where the graph crosses the x-axis.
Yeah.
Okay? Maybe not 3 of them. Maybe not all 3 of them, but up to 3, right? So now what's step 2?
Check graph on Desmos for PRRs.
Okay. So we're going to graph it on Desmos. Check Desmos. And I did this before we started.
Smart.
So if we look at Desmos, now,
Use the
I mean, it's a cubic graph. So it's just kind of angling up.
That's crazy.
Oops.
There you keep going.
What value are we touching at? Or crossing at?
Plus or minus 2. Positive 2.
That's a positive 2, yes?
Yeah.
Do we see any other places it crosses?
I don't know. It does not.
Okay. We don't see any other places it crosses. And here's the deal, guys. Remember, my biggest PRR and smallest were plus or minus 10. I have that whole view showing here, and I don't see anything else. So the only place that it has a real 0 is x equals 2. Okay, so we're going to go back and use that. So we're going to try or use x equals 2. Okay. Step 3. Step 3 is to use 2
Synthetic division.
with synthetic division. So, next to 2, I'm going to have 1, -2,
2,
5,
-10.
-10. Okay. 1. 2 times 1 is 2. -2 plus 2. 0.
0.
2 times 0.
0.
0.
5.
5 plus 0.
Yep.
5.
2 times 10 is 10.
2 times 5 is 10.
That's what I meant.
-10 plus 10 is
0. No remainder.
0. Okay. No remainder is a good thing, right?
Yep.
That's what we expect, especially since we just checked the graph and we saw that it worked on the graph. Now, what does 2 represent as a factor?
2 as a factor is x,
X.
minus 2.
Minus 2. So if we're talking about what we have in the way of factors, we know so far we're going to have a factor of x minus 2. Okay? Now, might as well go ahead and talk about it while we're here. What does this 105 represent?
That is your.
What'd you say?
X squared, the x, and then
That's your new.
That's constant.
It is. So because this originally was x to the third, we're now at x to the second. So this is x to the second plus 0x, which I don't need to write as 0x, and then plus 5. Okay? That is our other factor. Now, does x squared plus 5 factor anymore? No. Okay? We know by looking at our graph, we still need 2 more answers, but they're going to be imaginary because we couldn't visibly see anything else. Okay? So, actually, what I just did for you guys right here is if it asks you to write it in factored form, that's factored form right there. The x minus 2 and the x squared plus 5. Because I can't factor x squared plus 5 to finish my problem. I'm going to have to solve in a different method. Okay? Now, gentlemen, focus please. Step 4 is we need to solve, right? We need to find all of our zeros, which we already talked about, the x minus 2, and now we also have x squared plus 5. I'm going to rewrite it here, although we already know it. We know that x minus 2 equals 0, so we know one of our answers, one of our zeros is 2. We already had that, right? The question is about the x squared plus 5. Nice part is, when I set x squared plus 5 equal to 0, I don't have to use quadratic formula in this one because there's no x term. Because there's just a squared term and a constant term, we don't have to use quadratic formula. It won't factor, unfortunately. But how do we solve x squared plus 5 equals 0?
You subtract 5.
Subtract 5.
And then you take the square root.
Okay, x squared equals negative 5. And then we will square root. When we square root, what is the square root of negative 5?
Square root. Plus minus.
Okay, I've heard all the pieces. When we take a square root in the equation setting, don't forget plus or minus. Square root of a negative means we're going to have an I. Square root of 5, I can't do, so I'm going to leave it as square root of 5. How many answers do I have?
3.
3. 2 is an answer. And plus or minus is 2 more answers. So we have the 3 answers we are expected to have.
Wow.
Okay?
This is a lot easier than yesterday.
Okay, and these, okay, that was factored form over here. These are my roots. X equals 2 and x equals plus or minus I square root of 5. Those are my roots. And I'm just trying to help you be prepared for vocabulary on the homework the best I can here.
Okay. Question.
Okay, so obviously minus quadratic formula, this one did work out a little bit easier. Yes, Aaron?
On the test, will we use Desmos or what?
I have not thought that far ahead, but you will not be using Desmos.
So,
I will, my thought would be that I would provide a graph.
that's what I was saying.
I cannot let you use Desmos because that opens up the entire internet and that's just downright stupid of me. So, okay? So, you will not be using Desmos. I would probably provide a graph.
Okay.
Fair enough?
Yep.
And the advantage of me providing the graph, you can't accidentally type in the graph wrong.
Very true, very true.
You know. I'm saving you a direction you can make a mistake. So,
Thank you so much.
okay, backside. Now, backside takes us a different direction. Okay?
Oh my goodness.
I'm not going to call it easy, but I definitely don't think it's any more difficult than that. In fact, I feel like, I don't know how to explain it. There's work here, okay? That's what I'm saying. There's work here, but it is very doable. Okay? I left a space for a reason, guys.
Oh my Lord.
Okay? I leave.
That leaves room for mistakes.
I will say, okay, so what we're getting ready to go into, there is a lot of room for careless mistakes. So, okay. On the back side, first of all, we're going to talk about this conjugate root theorems here, which I've kind of already addressed a little bit. And this says, if a polynomial has irrational or imaginary roots, then those roots occur in pairs. That problem we just did, it had plus or minus I the square root of 5. That was a pair of imaginary roots, right? It could have just as easily been irrational with just square root of 5. So they always occur in pairs. So if you have a positive square root of 5 as an answer, you're going to have a negative square root of 5 as an answer. If you have a positive 5i as an answer, you're going to have a negative 5i as an answer. So irrationals, which are your square roots, or imaginaries with your i's. Now, so when they always occur in pairs, think conjugates. And I don't know if I've used the term conjugates before. I've used it in one of my classes this year, but I don't know if it was Algebra 2 or if it was pre-calc. But the idea is a conjugate, if a plus square root of b is a root, then we know that a minus square b is a root. So notice it's the same piece, just the sign in front of the radical is opposite. Same thing with imaginaries. If a plus, that's supposed to say a plus bi. Okay.
A plus this.
Yeah, not a plus this.
A plus this a root.
That is a combination of a plus bi is.
There's
Okay.
no I.
As I said, typo.
Oh.
If a plus bi is a root, then a minus bi is a root. Again, conjugates. Taking the same pieces but changing that middle sign. Okay, keep that conjugate root theorem in your head. Okay, example A. What is a quadratic equation? What do I mean quadratic? Power of
4.
2. Quadratic means we're going to have x to the second, okay, in standard form with rational coefficients that has a root of 5 plus 4i. Now, quadratic. We just talked about quadratic means x squared. So how many solutions does this problem have? 2. How many did they provide me? 1. Okay, what did I just talk about? If 5 plus 4i is a root, then also 5 minus 4i is a root. Okay? So, you have to watch. If they give you imaginaries or radicals down the next problem, you have to make sure you have the pair there. They like to give you one and not tell you what the other is. They assume you're going to be like, oh, hey, imaginary, irrational. Okay? See the problem with me, please. So, they want this in standard form, which means they want it all multiplied out. Now, think with me. If this had been, say, just 5, what would you write that as a factor? If this was just a 5, your factor would be
Right here, x minus 5.
x minus 5, right?
Yep.
Okay. But my root is not just 5, it's 5 plus 4i. So we're going to write this as x minus the quantity 5 plus 4i. Notice I put x minus, and I put a set of parentheses around 5 plus 4i. The other root Or the other factor is going to be x minus, what's my other one?
5 minus 4i.
5 minus 4i. So this is what you have to watch out for today. When we think about those x minus 5 plus 4i, if I want to rewrite this without the parentheses here, this is x minus 5, and what happens to the 4i? It's going to be minus 4i. So x minus the quantity 5 plus 4i is really x minus 5 minus 4i. Let's do the same thing with the other one, and then I'll explain where we're going. This is x, distribute that minus 5 and
Plus 4i.
plus 4i. Okay, guys, those are the two factors that represent this quadratic equation. Now, where does it get a little tedious today? They want this in standard form. I don't know what my screen is doing here, but it's not cooperating.
There's a fly.
That's what my computer's doing, or my BenQ's doing. Okay, the fly wants to join the lesson. Are you done now? Thank you.
Whoa.
Okay.
Name it.
Whoa.
Fly or the fly?
Okay.
Ben the fly for the BenQ.
Okay.
Ben.
So that fly was obviously on there a little bit if it crawled and made that trail.
That was funny. Jared was like, there's a fly. I was like, oh.
Someone should have pointed out to me. I couldn't figure out why I couldn't change colors there.
What are you doing, Jared?
Okay. So, the idea here is, guys, they gave me a root. We know there's two roots then. We put them in factor form. They want them in standard form. We have to multiply them out. That's the hard part of this. Or maybe I shouldn't say it's not necessarily difficult, it's just tedious.
Tedious.
Make sense? So, let's go. So, I'm going to start with this x here. And I'm going to take this x and I'm going to multiply it by everything in the next parenthesis, right?
Oh,
Goodness.
good.
It's like a big old FOIL problem,
Great.
but extra big. So x times x, x squared. Okay, hold on. X times minus 5,
Negative 5x.
minus 5x. X times 4i. Think of the I as another variable. So if this is x times 4i, I'm going to write it as 4ix.
Oh.
Okay?
Now we're just throwing silly stuff out there.
Now,
When did we put the alphabet into algebra?
now we're going to take the negative 5 and we're going to distribute negative 5. So negative 5 times x
The negative 5x.
minus 5x. Minus 5 times minus 5
25.
plus 25. Minus 5 times 4i.
Negative 20i. Negative
Minus 20i.
Yeah.
And
Yeah, yeah, you got it.
minus 4i. We're going to distribute the minus 4i.
Plus, oh my god.
So minus 4i x minus 4i times x minus 4i times minus 5
Plus 20.
plus 20i minus 4i times positive 4i.
Minus 16.
No, wait, minus 4i plus
This is insanity.
I squared.
Minus 16i squared.
Yeah, brother.
Now, okay, because we multiplied basically a trinomial times a trinomial, 3 by 3, you should at this exact moment have 9 terms. Because we multiplied 3 terms by 3 terms.
Yeah.
Yeah, yeah. Just take
Now.
a glance at the board, then decide if you want to sleep or not.
Okay, your last step is cleanup. Now,
Combine.
good news, guys, when you get done with this problem, you should have no i's left.
Ooh.
Because they should all cancel. If you have i's left, you've made a mistake. Okay? Question?
How do you cancel a negative 16i squared when there's no other?
Yeah, hey, there's a
Okay.
I squared. Oh, doggone it.
Okay. So, as I look at this, I see a positive 4ix.
Oh.
That's going to cancel with a
Negative 4i.
negative 4ix.
Yeah. Oh, and a 20 and 20.
I see a minus 20i.
Minus 20i.
Cancels with a positive 20i.
Positive 20i.
Now, Landon had the question, my negative 16i squared is not going to cancel, but what do we know about I squared?
Negative 1.
That's negative 1. And so minus 16i squared is really plus 16. So it's just a constant. It's just a number.
So basically, the i's are just.
Yeah.
The i's are just 1.
The i's are what?
Just 1.
I squared.
I squared is negative
So
1.
wait, if you.
I is the square root of negative 1.
So if I had a negative 48 I squared, it's just plus 48.
Uh-huh.
All right. I think
Okay.
it's fine.
Clean it up, guys. Final answer. I see an x squared
X squared, so start with that.
minus 5x and minus 5x.
Minus 10.
It's going to be minus 10x.
And then you gotta add 25 and 16.
25 plus 16, which replaced the minus 16i squared,
You get
right?
40.
25 and 16 is
41.
41.
Is that it?
That is it.
Oh, that wasn't even hard.
Yeah.
Yeah.
I love you, Trin.
Okay, guys.
It was absolutely.
Serious questions I can answer right now.
Well, number 2 is just baloney.
Get out of here.
So, actually, yeah, was going to have a couple serious questions.
Okay, guys, don't, enough. Okay?
Shut it off.
We're going to worry about ourselves. We're going to make sure we know what to do. Okay. B. You guys have what you need from this screen, right? B and C are the same type thing, just variations. Again, you have to be careful. B asks, what is a polynomial function Q? So Q is just a random name. Of degree 4 with rational coefficients such that 2 minus square root of 3 and 5i are roots. So degree 4 means we actually need how many?
4.
Yeah, we're going to have, this is going to end up being x to the 4th. But I need 4 factors to multiply. They only gave me 2 sets of information.
Yeah, but you can
Okay.
got it.
So
Easy.
what do we know here?
Well, we know that 2
What?
minus square root of 3 is also 2 plus square root of 3.
Yeah. Don't forget that.
And what are your thoughts on the 5i?
Can you just do negative 4?
Yep.
Just negative 5i.
Choose one.
Okay. Now do I have 4 roots?
There are 4 right there.
Okay, there are 4 roots. If only it was this easy. They wanted a polynomial function like that, standard form. So, let's get it written out. First of all, I would definitely write the like pieces next to each other. It's x minus 2 minus square root of 3. I put the extra set of parentheses in first. If you want to go ahead and do that all as one step and take that extra set of parentheses out, you don't need them, that's fine. I'm going to also have x minus, and my other one is 2 plus square root of 3.
Oh my goodness gracious. Oh gosh.
Okay, there was a 5i given. So x minus 5i. And there's a negative 5i given, which officially is x minus negative 5i, but yes, we're going to say x plus 5i, aren't we? Before I start multiplying anything out, I want to clean this up. The x minus the 2 minus square root of 3, distribute the minus, so it's
X equals, or X minus 2 plus square root of 3.
plus square root of 3. Do the same thing with the other one. It's x minus a quantity, so x minus 2
No.
Oh my god.
minus square root of 3.
Minus.
This one's gonna have a lot
Okay.
of terms.
We have x minus 5i, and we have x plus 5i. Now, I have some important tips for you here.
Tips. Yes.
Okay. When we go to multiply these out, as stated, there's going to be a lot of terms. But it is hugely important that you multiply the conjugates with each other. So the two parentheses that have the 2 square root of 3's, multiply those together. Simplify, clean that up. Over here, multiply your 2 5i parentheses together. Simplify, clean those up. And then once we get that done, we'll multiply it all together.
So distribute the first and second parentheses set together,
Uh-huh.
and then the third and fourth together, and
Yeah.
then do them both together.
Yeah. So we're going to do that pair. We're going to do that pair. Okay? You can't do more than 2 at a time anyways, and it's important that you pick the like pieces to put together. Now, I don't think I'm going to try and draw all the arrows I drew last time, because I think it'd get a little crazy here.
What do you do? 3 times x?
Okay, so I'm going to take my x and I'm going to distribute it, right? So x times x, x squared. X times minus 2,
Minus 2x.
minus 2x. X times minus square root of 3.
Minus square root of 3x.
You can either write it as minus square root of 3x, just make sure that x is outside the radical, or you can say minus x square root of 3, which I think is what I did in my notes, but it doesn't matter. Now we're going to distribute negative 2. Negative 2 times x minus 2x. Negative 2 times negative 2
Plus bow.
plus 4. Negative 2 times negative square root of 3
I did plus yep, yeah, that's what I did. Yep.
What did you do? Minus.
plus negative times negative makes it plus, and I'm just going to write it as 2 square root of 3. And now I'm distributing square root of 3.
Oh,
Square root of 3 times x plus square root of 3 times x. Square root of 3 times negative 2 minus 2 square root of 3.
oh, that's canceled right there, baby.
Wait, we're not there yet.
What is square root of 3 times negative square root of 3?
Is it negative?
Negative square root of 9.
Okay. Negative square root of 9. Okay, that's one piece. We're going to have to clean that up seriously, right?
Yeah.
Now, don't forget, I'm going to go ahead and multiply the other piece too. So I'm going to multiply by 5i so I don't forget about them. And then I'll clean up. So, exactly why we're doing it now, because if you've already forgotten about it, you're doomed if we don't do them now. So, okay.
You have no room.
X times x, x squared. Hey, we only need room for 4 terms here.
4.
Okay? X times 5i plus 5ix. Then distribute the negative 5i. Negative 5i times x
Minus 5i.
minus 5ix minus 5i times positive 5i.
Minus
Negative
25.
25i squared.
But
That's
But-
basically.
I'll get in. Yep.
plus
We're getting
25,
there.
baby.
Okay.
No, you're less.
Okay. In my parentheses that has the 2's and 3's in it, there should be some canceling. And there should be some canceling in that, like on the i's, how the i's canceled out earlier.
Yes.
All the square roots should cancel out here.
All of them?
All of them will cancel out or simplify. So, minus square root of 3x is going to cancel with plus square root of 3x.
Okay.
Plus 2 square root of 3 cancels with
I'll be darned.
minus 2 square root of 3. And what do you know about the square root of 9?
It's just The square root, it's
3.
3.
It's 3, yes? Square root of 9
My brain
is
ain't
3.
working.
So that's really going to be replaced with minus 3.
But wait,
Okay?
there's a negative there, though. Shouldn't that be an I?
Right.
No, it's
This is
not.
just square root of 9. There's
Oh,
not I
it's
squared.
not inside the square root. Oh.
Okay. Now, we're going to clean this up. We have x squared
Squared minus.
minus 2x is minus 4x plus 4 minus 3
1.
is going to be plus 1. So all that mess cleans up to be x squared minus 4x plus 1 on the first one.
That's crazy.
Second part,
What do you got?
5x minus 5x
Cancel.
Yeah.
cancels.
Look at that. So then just plus 1.
Okay. I squared is negative 1. So negative 25 times negative 1 is really plus 25.
Look at that.
So that second parenthesis is going to clean up to be
X squared. Guys, come on. Plus
so that cleans up to be x squared plus 25.
Yeah. And then we distribute again.
Good news, bad news. Bad news, we distribute again. Good news, my radicals are done, my i's are gone. It's just more basic now. Okay? Okay. X squared times x squared. X to the fourth. X squared times 25.
Mm.
Oh my gosh, what's 4 times? Oh, it's 100.
X squared times 25 is 25x squared. Then I'm going to distribute my minus 4x. Minus 4x times x squared minus 4x cubed. Minus 4x times 25 minus 100x. Then I'm distributing my 1. 1 times x squared, 1x squared, 1 times 25 plus 25.
That's a lot of.
So I can find my term.
Final cleanup. And put them in order, okay? Put them in order. We have x to the fourth. I'm going to say minus 4x cubed.
Okay. And then there are 2 x squared.
25x squared plus x squared.
It's 25x squared.
Let's go with 26x squared.
Yeah, that's high.
That's what you meant.
Yeah. I didn't write that down.
Then we have a minus 100x
Plus
and a plus 25.
answer. Oh. You poor thing. You poor thing.
Okay.
You hanging on back there like bread on the road?
It is a lot. Okay, guys. Now, on C, we may or may not get all the way through multiplying this out, but more important, you guys have seen how the multiplying out works, okay? You've got the idea. There's work involved, okay? So,
Just a little bit.
with that in mind, the setup is important here, okay? So, this one, and I wrote this one in this form because there's one in homework of this form. Form a polynomial with real coefficients having the given degree and zeros.
Oh.
So degree 4 means it's going to be
X4.
x4. And how many zeros are there? Or how many factors are there? If it's degree 4, there's going to be 4 factors. Now, one of the zeros is 3 minus 5i.
So you know it's 3 plus 5.
So we know there's also a 3 plus 5i. Now, negative 1, multiplicity 2. What's that saying?
-1 plus 2.
Now, there's going to be a negative 1 and there's going to be a negative 1. In other words, it means negative 1 is going to occur twice.
Oh, that's right.
So you're going to have the same factor twice.
Oh,
Oh, and is that for the 2, 2? 2, 2?
No.
It's -1 multiplicity of 2. So multiplicity of 2 is describing the fact that there's two negative
so if that
ones.
was a -10, it would have been -10 comma -10.
There'd be -10
So
twice.
if it says multiplicity, then I need
And
to
if it
write
was
down
multiplicity
that
of-
same number twice.
If it was multiplicity of 3, there'd be another -1.
3.
All right.
Okay.
Okay.
Let's set it up. 3 minus 5i. I'm going to say x minus the quantity. 3 minus 5i. 3 plus 5i. I'm going to say x minus the quantity. 3 plus 5i. Minus 1. So there's going to be an x minus -1, which, yes, is going to turn into an x plus 1. Multiplicity 2 means I'm going to repeat. Or in other words, it's x plus 1 raised to the power of 2. Because remember, multiplicity is your power.
So,
This is great.
Okay, we're going to clean this up.
Oh, you're right.
X minus 3 plus 5i. X minus 3 minus 5i. X plus 1. And x plus 1. Those are essentially your 4 parentheses you need to multiply out. Do your 1s with the i's together. Do your x plus 1s together. Get those answers, then multiply again. And I can guarantee that I have taken up too much space and I'm going to run out of room.
Uh-oh. That's done.
I've written too big. Okay. Okay, I'm going to do x times each of these 3 pieces. X times x, x squared. X times minus 3, minus 3x. X times minus 5, I, minus 5ix. Then I'm going to distribute -3. -3 times x, minus 3x. Minus 3 times minus 3, plus 9. -3 times -5i, plus 15i.
Holy cow, I just did that.
Now I'm going to multiply the 5i. 5i times x is 5ix.
get that guy out of there.
5i times -3 minus 15i. And 5i times -5i minus 25i squared. I just multiplied a 3 by 3, so I should have 9 terms before I clean up. Now, I don't care if it's now or later, don't forget about
You gotta distribute.
the x plus 1s,
Distribute still.
right? Don't forget about the x plus 1s.
There's a lot of one.
I'm
X-
cleaning up now.
X times x, x squared. X times 1,
X.
1x or x. Then distribute the 1. 1 times x, 1x, 1 times 1, plus 1. Okay. As with all of these others, there's cleanup, right? Minus 5x cancels with plus 5x. Plus 15i cancels with minus 15i. Minus 25i squared is going to become
25.
plus 25 when you clean that up.
Oh, goodness. There's a lot of numbers here.
Okay, I know I have an x squared. Minus 3x and minus 3x. It's going to be minus 6x. 9 plus 25 is 34. That's my first parenthesis. My other parenthesis, x squared plus 2x plus 1. And you're multiplying one more time. One more set of multiplying. So now we've got 3 by 3 again. We're going to get 9 terms and clean that up. So I'm going to distribute x squared. X to the 4th plus 2x cubed plus x squared. That's distributing the x squared. Distributing my minus 6x. Minus 6x cubed minus 12x squared minus 6x. And then distributing 34. 34x squared, 68x, and 34.
Wow.
You did it, man.
We'll put this in.
I know, I'm going to make it work barely. X to the 4th,
Find your x
2 minus 6
negative 5.
minus 4x cubed. X squared minus 12 is negative 11 plus 34.
20.
Is it 23x squared?
Yep.
Minus 6x plus 68x plus 62x plus 34.
Easy.
And I agree with my own answer, Keith. That's good. Okay, guys, you have homework due tomorrow.
Oh, God. More than. You don't understand. I look back and I'm like, see, like, oh, wait, he's doing a good job. And I was like, he's so like,